Welcome. In this lecture, we're going to return to another example in kind of our mission to understand this notion that if you're looking at all the possibilities of values that satisfy some kind of relationship, it's often give you a shape in one of our Euclidean spaces, like R2 or R3 or any R to the end. Okay, so this example should be a little bit familiar, or if not, this will be the first time you'll see a new example. So what we're going to look at, so this is example 2 in R2. So we're still in the kind of standard Euclidean plane. And we have our two axes. So I have my x-axis and my y-axis. And then what I'm going to look at is I'm going to look at a circle of a particular radius. Okay, so I'm going to have where this is going to be. So I have some kind of radius here. So all points on the circle are distance r from the origin. And so this is going to look like x squared plus y squared equals, and then this is going to be the radius squared. That's the equation for a circle of radius r. And then, right, so to give a little perspective of what's going on here, this is at r, this is at minus r, this is at r, this is at minus r. But all of the points along here are precisely of distance r from the origin. So what do we have going on here, as I kind of was saying a little bit there, which is that the points right, so these points x, y on this circle, so on this, so let's make this blue so you can tell that this is what we're talking about. So this circle of radius r right? These are precisely those with are precisely those where we're going to have that if I take x squared and I add y squared, then I'm going to get my radius squared. Okay, and for example, so I could look at a point on there. Okay, so I'm going to have some kind of point that's going to be minus 4, 3, and we're going to assume then this is a radius 5. So I have minus 4, 3 is going to be, so it's going to be a little further this way than it is, minus 4, and then it has to go up. So we're going to minus 4 a little bit further this way than up. So somewhere around here, I have a point minus 4, 3. Okay, so this point, minus 4, 3, and it's okay that one of them is minus, it ends up squaring, so you still get that radius, because squaring makes things positive. So minus 4, 3 lies on the circle. So now it's a circle of radius 5, so circle of radius 5. Okay, so that's going to look like, so we have, right, the circle of radius 5, which is, so we have x squared plus y squared has to equal 5 squared. And if you check, you really kind of had this because you have, so you don't kind of have it, you actually have it. So you have minus 4 squared plus, and then we have 3 squared equals, and then 5 squared, 25. So this does actually equal this, because this is 16 plus 9. So that does actually equal 25. Okay, so all the points on here are precisely the ones of distance r from the origin, or the ones satisfying this equation. And for our real life example, there are actually lots that kind of satisfy this, but let's just kind of look at this as our real life example. Which is going to be, you could be looking at all points at a given distance from a starting location. So all points at a given distance from a starting location. For example, right, you could be looking at, actually what you could be looking at, just because of how like velocities and so on work, you could actually be looking at all points that you could reach, like if you're at a specific location and we're not taking into consideration the time it takes to kind of turn around or something like this, you're looking at all the points that you could reach in a set given amount of time, or that you could drive in a set given amount of time or something like this. So it actually gives you, everything that you can reach in a particular amount of time, or is a particular distance from wherever your kind of starting location is. Okay? So I hope that made some sense, and I will see you in the next lecture.